Hello students, welcome to Saurav's classes. In this video, I will be solving the following question from ISS 2017, paper 4. Now here we have to obtain the reliability function and the hazard function for the Weibull distribution. This Weibull distribution, it is a continuous probability distribution. It is a continuous probability distribution with shape parameter lambda and scale parameter as theta. So its PDF is given by, its PDF or probability distribution function is given by f of y. This is equals to lambda into y raised to the power lambda minus 1 into theta raised to the power lambda into expectation of minus y by theta, this raised to the power lambda. So f of y, this is equals to lambda into y raised to the power lambda minus 1 into theta raised to the power lambda into expectation or e raised to the power minus y by theta raised to the power lambda. Now we have to find the reliability function and hazard function. Now first, this reliability function, or which we also called as survivor function, this function gives the probability, this function gives the probability that a patient or a device or an object or any other object this patient or device or this object, it will survive, beyond any given specified time, beyond any given specified time. So this reliability function, it is a probability that a patient or device or any other object, it will survive beyond any given specified time. And so we would have this reliability function, reliability or the survivor function that denoted by SYY. This is equals to probability that the object under consideration, it will survive beyond time y, that is capital Y is greater than small y. So SYY, it is equals to probability that capital Y is greater than small y, which is equals to integration y to infinity lambda into t raised to the power lambda minus 1 divided by theta raised to the power lambda into expectation t by theta raised to the power minus t by theta raised to the power lambda into dt. So the survivability function would be given like this. Now this is equals to, now let us define a variable z, which is equals to t by theta raised to the power lambda. Then dz would be equals to lambda into t by theta raised to the power lambda minus 1, lambda minus 1 into 1 by theta into dt. So dz is equals to lambda into t raised to the power lambda minus 1 divided by theta raised to the power lambda into dt. And when t is equals to y, our z would be equals to y by theta raised to the power lambda. And when our t is equals to infinity, then our z would also be equals to infinity. So we would have this probability y is greater than y. This is equals to integration y by theta raised to the power lambda to infinity e raised to the power minus z into dz. So this is equals to minus e raised to the power minus z. It is from infinity to y by theta raised to the power lambda. Now we know that e raised to the power minus infinity is equals to 0. So this would be equals to expectation or e raised to the power minus y by theta raised to the power lambda. So our survivability function, that is SYY, this is equals to expectation of by e raised to the power minus y by theta raised to the power lambda. So this is the survivor or reliability function. Next is the hazard function. The hazard function which is also known as failure rate or force of mortality, it is the ratio between the PDF and the survivor rate. So it is the ratio between the probability density function to it is the ratio between the probability density function and the survivor function or reliability function and survivor function or reliability function. Hence the hazard function denoted by HYY, this is equals to the ratio of the PDF denoted by FYY and the survivor function or reliability function denoted by SYY. So this is equals to lambda into y raised to the power lambda minus 1 divided by theta raised to the power lambda into expectation of minus y by theta raised to the power lambda, this divided by expectation minus y by theta raised to the power lambda. So if these parts get cancelled out, so we get our hazard function denoted by HYY. This is equals to lambda by theta raised to the power lambda into y raised to the power lambda minus 1. So our hazard function is given by lambda divided by theta raised to the power lambda into y raised to the power lambda minus 1, where this lambda is the shape parameter and this theta, it is the scale parameter.